This is part A of the wind tunnel simulation. .1176 meters. H2 will be 1.2192 meters. H3 will be 1.5748 meters. I'm going to do constraints. We want to find midpoint. And then bring these over. And then we can do dimensions on those. So this one, and then one of these. And then we're going to go back to constraints and do equal length for these two ones at the center. Okay. So for V4, we want it to be 1.1166. V5 should be 0.6096. Actually, I have the wrong one. 0.889. 0.6096 for this one. Point 6256. Okay, that looks good. So now we should draw lines to create the walls of the wind tunnel. And we can modify and delete the supporting lines. Okay, and then we can draw the inlet and the outlet. Okay, concept, surface from sketch, box select, apply, and generate. What am I doing wrong? Okay, that is kind of weird. It didn't line up exactly. That was kind of weird. None of these want to line up exactly. Ah, perhaps it wasn't actually vertical. Okay. Should be an easy fix. Just make a line right here. to constraints. And then constrain these. And then make sure these are vertical. And that these are horizontal. And make sure those dimensions are correct too. Yep. That's good. Okay. So definitely make sure that your lines are vertical before you try to do what I just did. Let's see. Okay. So now it generates the object. So we close out of that and start doing the mesh. Definitely helps if you don't have a slower computer, but a little bit extra time doesn't hurt. Okay. So insert method. Triangles. Okay. And then 0.01. Generate. Okay. The computer's not done meshing yet. Okay. This is looking good. Okay. So now I'm going to do edge select. And we want to start naming the inlet, outlet, and the walls. So this would be the inlet. Velocity inlet. And this will be a pressure outlet. This will be non-slip wind tunnel walls. Okay, so recheck our mesh. It's not perfect, but it looks good. Our names, so sections, inlet, pressure outlet, and the non-slip tunnel walls. Okay, we can close that. And then update. Okay. Why it's not? Okay. Double precision. 2 solver. Start it. Okay. It's just about loaded. So the fluid should be air. 1.225. We're going to keep it at 1.7894. Okay. So we want to put in a velocity at the inlet that will cause it at the test section to be 15 meters per second. Put in 5.625. And of course, if it doesn't come out as 15 meters per second, you can always go back and change it. So. The outlet. I'm going to prevent reverse flow. And the wall should be non-slip. Yep, stationary. Yep, it's good. Okay. Reference values, we'd be computing from the inlet. These should be the same as the ones you put in earlier, or the same as they were if you didn't change them. Okay. Now we can initialize it. We want to change this to 25 or 30 iterations and initialize. Once that is done, we can run the calculation. Let's do 120. Okay. So now we want to start doing the contours. So we we want to get the pressure, velocity, total pressure, and dynamic pressure contours. So we'll go to plots. Okay, so in graphics, we do the contours there. And we want to do banded. First, let's do the standard pressure. The static pressure. And then select all of those. Okay. We want to take a screenshot of each one of these. And this will just be the pressure. Then we want to do the velocity, magnitude, display that. Okay. And then we want to do the pressure of total pressure. Okay. I want to take a screenshot of that, save it. Okay, and then we want to do that dynamic pressure. Probably should rename all those as contours because we do not want those to get confused with later graphs we make. Alright, once we change that, we want to insert a streamline. should work. Let's do 50. Okay. I want to take a screenshot of that. Okay. We want to go back to this. Now we want to go to XY plot. We want to insert a new line. This will be the horizontal line. We want the endpoint to be right in the middle of this end. So we can make calculator. Point 1176 plus 1.2192 will be 2.3368. And we want to go up to, well, minus. We want to go up to 1.5748. Let's create that line. Then we want to do a vertical line. So we want to go from 0, 0. We want to go from y is 0 to y is 0.60. Actually, 0.6096 over 2, 2.3048, 2.3048. Create that line. Okay. Now we want to do the static pressure, velocity, total pressure. So I'm going to do it around the horizontal line. We want to do pressure, static pressure. Okay. Now we want to do the velocity magnitude. Okay. That's good. Now we want to do the pressure, total pressure. Okay. We want to change this around a little bit. Okay, still not very pretty. So I guess let's keep it like that. This would be the static pressure. Actually, okay. Now we want to do the dynamic pressure. Okay, that's good. Now we want to do it about the vertical line instead. We want to do the static pressure first. Okay, I'm going to change this to 0, 1. Okay. We want to do the velocity. Okay. Now I'm going to go back to pressure, and we would like to do total pressure. Okay. And the dynamic pressure. Okay. That's good. Okay. That will be all for section A of the wind tunnel experiment. Okay, for part B, we will copy what we used in part A. Basically, we already have the geometry made, so all we have to do is add the circle. dimensions, general. Want this to be 1/10 of the height right here. So 0.06096. We want the length from this to this to be 0.6096, which would put it directly in the center. Okay. Once you finish that, you can go back to Surface Sketch, Edit Selections, Apply, and Generate. If it looks like this, it should be good. Okay, you can go back to Workbench. It's already updated, so now you can go to Mesh. Okay. Once that loads,
Look at you like that tone of voice.
okay, it already has the triangle method from last time. However, we do want to insert sizing around the circle. Okay, generate. And then once that is done, we want to name the cylinder. I'll just do cylinder. Check the mesh. Should be finer around the circle. Looks good. We can go back to Workbench, update the mesh, and then we can go to Setup. Two solver processes with double precision. Start that. It's important to let it load all the way before really messing with it. My computer fans are going crazy right now, so if I mess with that, it could create a problem for my computer. That's good. Okay. So we want to check the material. Should be fluid, air. that's good. Want to go to viscous. We want a K epsilon. We want standard, enhanced wall treatment, let's select that. Should help. Okay. So let's go to some conditions. Should be fluid, air, reference values should be from the inlet. That looks good. 1.225, 1.7894. It's good. Boundary conditions, we want the inlet to have around a 5.65 velocity. The walls should be both non-slip. Stationary non-slip, that's good. Stationary non-slip, that's also good. Okay, let's initialize it. Then run calculation. Okay, it's done. So let's go to graphics. Let's do contours. For the first one, let's do banded. Let's do pressure. And then we want it especially around the cylinder walls. Just select everything. Pressure, static pressure. Okay. let's see what the velocity one looks like. Okay. I'm gonna go back and try something. Back at viscous, I'm going to get rid of pressure gradient effects. Then I'm going to reinitialize. Okay. Let's go back to contours. And then try that again. Okay, that looks a lot better. So do not select pressure coefficient. Or I forget what it was. Okay, I'm gonna do a large version, and then I'm gonna do a zoomed up version. I'll see this. This will be the it was a pressure. Yeah, it's the save. And then we want to zoom in. Okay, now let's do the velocity contour. Okay, and let's just check something real quick. I'm going to do a plot of the velocity at the vertical line. Okay, should be at about 15. I believe that looks good. 15 meters per second. Okay. I want to do an XY plot. We want to do pressure coefficient. We want let's see, pressure coefficient. Okay. Pressure coefficient. Okay, we want to do it interior surface body around the cylinder walls. Yeah, let's just do it around the cylinder walls. Okay, looks better. This would bring the pressure coefficient around cylinder. Okay. So now we want to exit out of that, go to part definitions. We want to add a new force report, then we want to select drag. And then, okay, that did not work. Forces drag. Okay, it opened that time. Okay. Now we want to reinitialize it. Then we can run a calculation. Let's do 75 this time. Okay, we want to go back to report definitions. Okay, that is really annoying. It did not save my force report. Oh, that's why. Gonna have to reinitialize that. Now we can compute that. Okay. There we have it. We have the...
You will need to unlock your device first.
Okay, save as... coefficient. Okay, once we're done with that, let's go back to Workbench and start part C. So again, we want to copy the geometry. We want to open geometry. And then we're going to go to sketching. It says a thin line. A thin flat plate. So first I'm going to try it as just a line. And then later, if that does not work, I will create some actual width to it. Dimensions should be 0.5 meters, I believe. And then distance. Should be 0.356. Okay. Okay. Actually, I am gonna width. Because I don't believe that this will actually affect anything if I leave it how it is. Okay. Midpoint. And then you do want to draw these first, otherwise it's going to be so small that it won't be able to. Okay, modify, I'm going to delete that. Then for constraints, I'm going to set these as equal length, these as equal length, and then I'm going to change this to be very small, like 0.01. Let's try that. Okay. Looks better. Now we're going to go to constraints. Not equal length. We want to do midpoint of this one. It should be at the center line. Okay, let's try dimensions instead. Do length. This should be 2.05. Okay, that looks better. Now we want to go back to modeling and edit the selections, apply, and generate. Okay, should look like that. Go back to workbench, and we can open the mesh. Okay. So I'm just going to start creating the name sections. Okay, that's good. Okay, we want to insert sizing. And then we're going to select all 4 of these sides again. Okay. Apply. We're going to do it by number of divisions. Let's do 400. Hopefully that doesn't take too long to do that. We're going to turn it to no for capture curvature and behavior hard. Okay, that looks good. Let's generate that. Okay, that was quick. Okay. It's not perfect, but it looks good, and we'll get good data. Okay, let's update the mesh, and then open setup. Okay, again we want to do 2 solver processes in double precision. Okay. Once we believe that is done, then we go to models, viscous. We want to go K epsilon, standard, enhanced wall treatment. Okay. Then we want to go to materials, fluid air. And we want to make sure it's at 1.225 and 1.7894. Okay. Now we want to go to cell zone conditions, fluid, and make sure it's air. Okay. Now we want to check the inlet velocity. Should be at 5.625. That's good. We want to go to the wall. Make sure both of these are on slip, stationary. Stationary wall, non-slip. That's good. Let's check the thin plate wall. Non-slip, stationary. That's good. And then let's go to reference. Reference values actually. Should be from the inlet. That's good. Make sure those numbers are the same as you put in earlier. Looks good. Okay. So I'm going to put in a force report for the drag. I'm going to call this drag coefficient. And I'm going to do it over the thin plate. Okay. Now I'm going to I have mine preset to 25 iterations. However, usually when you start the program, it's only in 10 iterations, I believe. So you just go to settings and change that. Okay, and run calculation. 120 iterations is good. You don't want to do too much because then it will take a long time. It depends if it converges or not. Okay, so we want to go to graphics, contour, and we want to do a pressure one around the thin plate. I want to do banded. Let's display that. Okay, we're also going to have to do the interior surface body. Display that. Let's move this out of the way, take a screenshot. Okay. Now, let's create a folder for part 3. Okay, this is gonna be the pressure contour. Then we're gonna want to zoom in around there. Okay, that's giving me the same error as earlier. go back and change that in viscous standard. Okay. Did not select that. Perhaps in the port definitions I might have to delete drag coefficient temporarily. And then I'm gonna have to reinitialize. Okay, let's go back to contours. Do pressure contour around the flat plate, banded. Let's also do the surface body. Okay, it's still showing those lines. Okay. That is kind of funny. Okay, so just don't select anything, and then it shows it properly. Okay. I'm going to do a new, and then I'm going to save this in the last one spot. And then I'm going to zoom in. I'm going to select that just to keep the name, and then rename it. Now let's do the velocity. Ooh, that one looks more fun. Let's take a screenshot of that. This would be velocity contour. I'm going to zoom in around it. Okay, exit out of that. We're going to go to plus XY plot. We're going to let's see. Go to wall shear. Wall fluxes. Wall shear. I'm going to do it around the thin plate. To the plate wall, there will be an wall. Okay, they're not looking like the greatest graphs. Let's try this. No, I just messed it up. Okay. This will be okay. Okay. And then let's go to report definitions. New force drag. Okay. Around the thin plate. Let's reinitialize. Okay, let's go back to report definitions. We're going to compute it. Okay. Okay, that will be all for part C, which will be all for lab 4.